Hello, everybody. Welcome to SRA 365. I'm, of course, Professor S, and this is today's lecture. So first, we'll go over the practice problems that were due for class today. All right, so we will go over more hypothesis testing next week, but I want to kind of go through normal distribution a little bit more because we have all sorts of different ways to find different values of the underneath the curve, and I kind of want to try to bring them all together as we introduce more of them. All right, so the idea is with normal distribution, we can there's different kind of shapes to it, but there's kind of a consistency to it. And I figured there's a visual element that we might be able to leverage here to help kind of understand that a little better. So anyways, what I have here is 4 different normal distributions that I tried to make them, the thing that differs between them is what the population mean and population standard deviation are for each one of them. And one of the things that R does when it graphs these, I changed the X limit, but what it does is it kind of stretches things out. So in order to really properly compare these, you have to look at the numbers for the scales. And so each one of these has the same x-axis. That's why they're kind of skinnier or wider depending upon them. But it's kind of harder to see the kurtosis for these because of what R does. And sometimes that matters and sometimes it doesn't. I feel like it kind of matters here to kind of emphasize the different the different normal distributions that we're using and how we're able to what we're finding for them. Okay, so anyways, this is where the mean is, and to kind of get a better idea for the different shapes of them, this is kind of what they all look like on the same scale of y and x. And so notice that we have different means, different population standard deviations, and that's great. But what if we had the same z for each of them? What does that mean? So let's say we have z is 1.5 for the one on the top left, then that means that the value of x. So remember, when we're finding the areas under the mean or under the curve, for in R, we have to refer to the values on the x-axis. And so z, in this case, we have to plug it in, and we get x is 9. And how we got that is 6 plus 1.5 times 2, that is equal to 9. And so we're looking at if we want to find the left of that z score, then we need to find to the left of 9. We put in 9 into R, and I'll do that in just a second, but that's what we're using. So the value of x in this case would be 9. For the one on the top right, for still z is 1.5, x would be 11. For the bottom left, we have z is still 1.5, so that x would be 15. And then for the one on the bottom right, that's standard normal distribution. So that means that the z-score would have the value of x would be 1.5. So the z-score and x are the same on standard normal distribution, and that's great. And there's that's kind of important, and we'll kind of see that in just a second. So anyways, when we're looking at the area from that z-score to the left, or that value of x to the left, we're finding this area right here. Okay. And then for the one on the top right, it's that area right there. For this area, for the bottom left, and then for the bottom right. And so that's for those different x scores. And so in order to find out what that area is for the one on the top left, we have to put in to R the x value first, the mean, the standard deviation, and then we want to say lower tail true. And lower tail true is going to be true for each one of them because we want to do to the left of that value. But notice that we're using that x with that mean and that standard deviation. And the way that we were able to find these x's that we're plugging in for this code was by using that z-score. And then also notice that if we were to run this, each one of these lines of code, we would get the same percentage from each one of these. That's what that line reads. So the idea is like when we're like the connection with the z-score with these different normal distributions, we have to think about like what values we're putting in here. Okay, so z-score is great because it gives us a nice consistent value, but depending upon what we put in there. So the first value has to be x, and we can use the z-score to help figure out what x is based upon the different, the mean and standard deviation. And then for the last one, if we just use that z-score, we could just find out what any of them are based upon the standard normal distribution, hence why it's called standard normal distribution, because we just put in the z-score in there. So sometimes we're given the z-score, sometimes we're given the value of x. And so when we're given the z-score, like for instance, when we're finding z star, we're given the z-score and we're trying to find what the value is, then we just use standard normal distribution. When we're given an x and we know what the mean is for our normal distribution and our population standard deviation, we could just plug that in for our values here. And that's kind of really what I want to emphasize is the difference between when we're using the z in our methods in R and when we're using x. And the great thing about, like I said, the z-score is like it finds that consistent percentage amount underneath the curves. So hopefully that helps. To also further cement this, I have the practice problems that are posted as of this recording that should help. And we'll return to doing hypothesis testing next week. So anyways, that's what I have for you guys for today. And I'll talk to you all Monday. Bye. Hey everyone, I hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message in Canvas to both me and the rest of the teaching team, and we'll get back to you as soon as possible. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for when I post the next video. Anyways, I think that's good for this video. I'll see you all later. Bye.